So in this chapter, let's have a discussion on thermal properties of matter. Now when you hear the word thermal, it is related to your heat. So what actually is heat? Heat is a form of energy. Heat is a form of energy. Now, if heat is a form of energy, then the next definition that you come to is temperature. Now, temperature is directly related to heat. Now, there are various definitions regarding temperature, but one of the most used definition of temperature, that the way you can understand temperature is the amount of energy that is heat energy present in a system. Another such definition is the degree of hotness or coldness. So these are some of the definitions that you come across of temperature. So if I want to define temperature, that is, suppose that temperature is very low. A substance has a temperature which is very low. So let this be the body of mass m. So if the temperature is low, what we can understand is that the amount of heat energy at this particular object is low. Now, we know that refrigerators, what they do is they make the object cool. That is, they make the object less heat. Now, there is the word cold, but what is actually the word cold? Word cold actually has no meaning. Cold means actually absence of heat. Absence of heat can be referred as cold. So as such, we have no concrete definition of cold, but only thing we can define cold as a degree of hotness. So if the degree of hotness is less, then we define the object to be cold. Now what refrigerators does is, a object, it reduces its heat energy. It reduces its heat energy how? By doing work. How? You supply electricity, and therefore because of some chemicals like CFC, which is a cooling gas, it takes out the heat from the object. So that's why it becomes cold. So now we have a vague definition of what is heat. Heat is defined as a form of energy, like mechanical energy, electrical energy. So heat can also be defined as a form of energy. Now temperature, that is closely related to heat, is the amount of energy, that is the heat energy present in a system, can be regarded as your temperature. So let's understand how in our physical world we have derived ways of measuring temperature. So there are various ways of measuring temperature. Now, one such measuring devices that we use is thermometer. So if you look at the word thermometer, this is thermo. The word thermo means temperature or relating to temperature, that is thermal. So what is the function of temperature? And how do we measure? What is the criteria that everyone accepts? This particular measurement, because we just can feel what is heat and what is cold. But how can you measure it? So a criteria was developed to measure temperature. Now there are certain liquids, or say solids, these are liquids, which reacts this particular substances, which reacts to heat. Now, all the substance in the universe reacts to heat, but why do we take particular substances that reacts to heat? That is because we take all those substances, that is for a slight increase in temperature, that is for a slight increase in temperature, there is a uniform increase in volume. So this is the definition, or this is the criteria that we can use while measuring temperature. Now what actually happens is, say suppose this is your substance. Now if you apply heat, there is a change in volume. That is, this particular substance after application of heat has increased to, say this was the original volume, has increased its volume. So this is the increase in volume. So for a specific amount of heat, we know there is a specific amount of increase in temperature over here. Specific increase in temperature. So this criteria has been used to measure temperature, and therefore we have come up with units, that is Kelvin or Celsius, degree Celsius. So these are some of the units that we have come across, that is if you put in this much amount of heat, a unit volume should increase. So let's talk about the mathematical aspect of this unit increase in volume. Now let's take the example of the mercury. Now what happens is, mercury also behaves like a temperature expanding agent, that is for a small given temperature the volume of mercury also increases linearly, and which is directly proportional. So what it does is, it takes a capillary tube. Now this capillary tube has a unit cross-sectional area, and this tube is made in such a way that if we take the degrees to be, say suppose if I have my temperature to be 1 degree to 2 degrees, so there is a uniform increase. That is, we have made the thermometer or the liquid put in such a way that for a gap in the increase in temperature, there is a uniform increase. Say suppose this much amount of temperature is there, so there will be an increase of say 1 degree. Now if the same amount of heat, the gap between the initial and the final, this is say 1 and this is a stage 2. Now if the same amount of heat is again supplied, that is the difference between 1 and 2, so we will have a 3 over here. From 2 to 3, a same amount of heat has been supplied, so there is a uniform increase in volume, that is 2 degrees. So this was the criteria that we had. Now this was on degree Celsius, but sometimes you hear of the unit Kelvin, the word Kelvin. So Kelvin, when there is no change in volume, when there is absolute zero temperature, because it starts from 1, 2, 3, 4. So when there is absolute zero temperature, we have taken Kelvin to be 0 Kelvin. So Kelvin starts from over there. So Kelvin is starting from over there, and there is another unit of measure, that is Fahrenheit. So what does Fahrenheit tells us? So this is the correct unit, and this is FC, Fahrenheit. This is, sorry, F, temperature F. So if you're talking about temperature in Fahrenheit, there is also a relation between different units. So if you're talking about degree Celsius and the relation between Fahrenheit, so these are some different units of measuring temperature. But since this is a measurement of temperature, so we understand that there should have a common link, and the common link is given by this particular equation, that is T, temperature for Fahrenheit, minus 32 by 180 is equal to temperature for Celsius divided by 100. So this is the relation that has been made with the degree Celsius and Fahrenheit. And if you talk about Kelvin, like we talked about Kelvin, so at absolute 0 degree, that is absolute minus 273 degrees Celsius, you have 0 Kelvin. So the relation between Kelvin and temperature can be easily found out. And the relation is temperature in degree Celsius is equal to Tc plus, that's the temperature in degree Celsius is equal to, this is temperature in degree, plus 273.15. This approximates to 0.15, or sometimes it says as 273. Therefore T equals to Tc plus 273 Kelvin. So this is a relation between degree Celsius and Kelvin. This is Kelvin. So if the temperature is 0, we have T to be 273 Kelvin.